I really hope your studying is coming along great this evening. This video is from page 405, number 13, and Megan is sitting in a rocking chair. Enjoy. So we're looking at Megan sitting in her rocking chair, and I've got some information on the screen already. So at time 1 second, the distance from the wall is 18 centimeters, and at 1.75 seconds, the distance from the wall is 34 centimeters. So to start a sketch of my graph, I'm going to put time on the x-axis and distance on the y-axis. And distance is in centimeters, and time is in seconds. So looking at my time first, you can see I'm at 1 second and at 1.75 seconds. So maybe I'll start at 0, and maybe I'll go to 3. So here's 1, 2, 3, maybe. Similarly for my y-axis, my minimum value is 18 here, and my maximum value is 34 right here. So there we are. So I need, at time 1, I need 18 centimeters. So let's just see what we can do here. If I go 10, 20, do an approximate scale, and now I'll put in my information. So the minimum happens at 18 at 1 second, so right about here. The maximum happens at 34 at 1.75 seconds, so up here. From the minimum to the maximum is half of a cycle, so to get to another minimum, that would be a full cycle. So observing how much time passed between this min and this max was 0.75 seconds. So to get to the next min, we got to go another 0.75 seconds. So that will happen at 2.5. So we've modeled our function, and the first question asks, what is the period? So the period would be the time from one minimum to the next. So in this case, it's 1.5 seconds. What does that minimum or that period represent? It represents the time it takes to rock back and forth. Part B asks, how far is the chair from the wall when no one is rocking in it? So that would be in the rest position. So if we're looking at our little Megan here, it's going to be somewhere in between, right in the middle, in fact. So she'll get out of it and it'll rest and it'll be in the middle. So what they're actually looking for is the equation of the axis. Looking at our graph, our maximum is 34 and our minimum is 18. So the axis is going to be in between those. So the difference between 18 and 34 is 16, and that means the amplitude would be 8. So 8 up from 18 would be 26. So I'm going to draw a line at approximately 26 that will cut the curve in two. So this is y equals 26, and that would be our equation of the axis. It would be 26 centimeters from the wall. Like I said, it'll be 26 centimeters from the wall when the rocking chair is at rest. The next question says, if Megan rocks back and forth 40 times only, what is the domain of the function? The domain refers to the time. So in other words, it's asking you what time would it take to do 40 cycles or 40 back and forth motions. Each cycle, we looked at the period, each cycle is 1.5 seconds. So 40 cycles, 40 back and forths, is the same as 40, and each one is 1.5 seconds. So that would be 60 seconds to rock back and forth 40 times. And we write the domain in terms of our t values. So this, we can go as low as 0 seconds, t, and is less than 60. That's our domain. Now we need to look at the range. The range is the set of y values, or in this case, the distance. The rocking chair has a minimum at 18 centimeters away from the wall. That's the lowest value, and the largest value is 34, so the range is between 18 and 34. The next question asks for the amplitude, and we already figured out our equation of the axis at y equals 26, so the amplitude would just be the distance from the equation of the axis to the max, or from the equation of the axis to the minimum. So in this case, the amplitude is 8 centimeters. And what this represents in terms of Meagan and her rocking chair is it's the distance, so 8 centimeters, from resting position either forward or back. The next question asks for an equation of the sinusoidal function. We could choose to go with sine, or we could choose to go with cosine. I'm going to choose to go with cosine because then I can look at the maximum of this new function and compare it to the maximum of the cosine function. So I've written down the general function here of y equals a cosine k x minus d plus c. So we need to know a, we need to know k, we need to know d, and we need to know c. A is the amplitude, so that would be 8. K is the, we find k by using k equals 360 for the parent divided by the period in the function given. Looking at our period, we already figured out it was 1.5. So k equals 360 divided by 1.5. Going back up here, k equals 360 divided by 1.5, which is 240. And then the x minus d. D is the horizontal translation, so I'll come back to that in a minute. And then the plus c is the equation of the axis, so that's 26, so because we'd moved the whole curve up 26. Okay, so observing our graph, we know that generally the cosine function starts at the max. So the parent function of this one would be the cosine function that starts at the max. So normally cosine starts at the max and go down and then back up again. So that's the sign we want to use, so that's why we chose cosine. So what I need to do is I need to think about if this 34 was over here, as if it were the parent function at the max, then what exactly did I move this way in order to get to the new max on our new function that we're doing down here at the bottom of the screen. So I moved it, that maximum is at 1.75. So I moved it 1.75 to the right. So I'm going to write minus 1.75 down in the bottom. So my final equation would be 8 cos 240 x minus 1.75 plus 26.